Hey, seventh grade math. This week, as we get started, we are going to talk about something called a sequence. A sequence is an ordered list of numbers. Ordered meaning that it has a pattern to it. And when we have a sequence, the vocab word for any of the numbers that are listed in our sequence are known as a term. Okay, those are just vocab words for you. And there are two different types of sequences that we are mainly going to be focusing on today. The first one is called arithmetic. Arithmetic is an old-fashioned word to meaning to add. So if we have an arithmetic sequence, we are adding the same number to the previous term or the previous number. But the important word to notice in there is the word the same. I have to be adding the same number every single time in order to make it a sequence. If I'm adding a different number every time, then I don't have a sequence because it has to be the same. But anytime you are adding the same number, it's an arithmetic sequence. And if you can remember A and A, they both start with A, that might help you remember the difference between the two. So an example of that is this. All of these numbers are called my terms, and if I jump from 2 to 5 to 8 to 11, you'll notice that in between each one, I'm adding 3. 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 3 is 11. So my pattern is I'm adding 3, and it's the same number every time, so this would be called an arithmetic sequence. Another type of sequence that we talk about are called geometric. Geometric sequences are when you are multiplying the same number to the previous term. So just like in the arithmetic sequence, you have to be doing the same number. But instead of adding, we are going to be multiplying. So if you look at my example down here, I start at 3, and then I jump to 6, 12, 24. If you notice the difference between the two of these here, your numbers start to jump quite quickly when you're multiplying. And if you notice from 3 to 6, if I multiply 3 times 2, I get 6. 6 times 2 equals 12. 12 times 2 equals 24. So my pattern is I'm multiplying 2 to each term in order to get the geometric sequence. So what you are going to be doing on your worksheet is figuring out whether it is a geometric sequence or an arithmetic sequence. And some of the times it's going to become a neither. And the reason for that would be that it's not adding or multiplying the same number each time. And we'll do a couple examples of those. But what you need to do is this. When you're given a sequence on your worksheet, you first have to decide, is it an arithmetic sequence, an adding pattern, or is it a multiplying pattern, a geometric sequence? And then you have to determine actually what the pattern is. Are we adding 3? Are we adding 5 every time? Are we multiplying it by 3? You have to determine what the pattern is. And then the last thing you have to do on each question is to find the next 3 terms. So if I know that I'm adding 10 to everyone, then I have to add 10 and find the next 3 numbers. And we will go over some examples of those for you. Here is how you kind of are going to want to do that. It says to look at the difference between the second and the first term. So when you look at the first 2 numbers, you're going to first see, what do I have to add in order to get from number 1 to number 2? And once you figure that out, try that for the third number. Did it work to add that same number? And if it didn't, then you go back and try again with a multiplying number. What times your first number gives you your second number? And then you try that on the third one. And if that works, great. If not, the answer might be neither. The pattern isn't there. And if you notice that the numbers start small and get bigger quite quickly, most of the time it's going to be a multiplying sequence. So here are a couple examples for you. The first one, it starts out, I have 4, 12, 36, 108. Our number all of a sudden jumps to 108. So that should be your first clue saying the numbers get big quickly, which usually involves multiplying. So look at your first two numbers here. 4 times what is going to give you 12? Well, 4 times 3 equals 12. So now we have to figure out though, is that the pattern? If I take 12 and I multiply it by that same number, 3, does that equal 36? Well, 12 times 3 equals 36. I can't do 36 times 3 in my head, but I can do it on a calculator. 36 times 3 equals 108. So on that one, we found out that it is a multiplying pattern. So you would write the letter G for geometric. And then you would write times 3. Let me write this down for you. So for number 1, I would write that it's a geometric pattern and that I had to multiply by 3 in order to get that pattern. And now you have to list the next 3 terms. So you're going to start with 108 and multiply it by 3. 108 times 3 is 324. So that's my first term. Multiply that by 3 again. You get 972. Multiply it by 3 again. I get 2,916. So for your answer for number 1, you need all these answers. It's a multiplying pattern, so a G. The pattern is to times it by 3, and these are your next 3 terms. Let's try another one. We go from 3 to 7 to 11 to 15. So our numbers don't jump that quickly, so we might want to start by looking if it's an adding problem. So 3 plus what is going to give you 7? Well, we know that 3 plus 4 equals 7. So let's check if that's our pattern. 7 plus 4 equals 11. 11 plus 4 equals 15. So it looks like that is our pattern. So if it's an adding problem, then I have to write A, or arithmetic, but you can just write A, and then you write that the pattern is adding 4. And then you have to write the next 3 terms. So we're going to start with 15, and we add 4, and we get 19. 19 plus 4 is 23, and 23 plus 4 is 27. So your answer is going to say arithmetic plus 4, and these are your next 3 terms in the sequence. Another example here. Now we start at 1, and then we jump to 2, 6, 24. That should be your first clue. Our number all of a sudden went from 1 to 24 quite quickly. So let's see how we got there. Let's check if it's a multiplying pattern. So 1 times what gives you 2? Well, 1 times 2 equals 2. So let's see if it's a multiplying by 2. 2 times 2, does that equal 6? No, it doesn't. And 6 times 2 doesn't equal 24. So we know it's a multiplying pattern, but it's not multiplying it by the same number. This is one of them where they try to trick you. So if you notice, 1 times 2 equals 2. 2 times 3 equals 6. 6 times 4 equals 24. So we are multiplying, but we're multiplying by a different number every time. So if this is the case, then you are going to write that the pattern, the sequence is neither. It's not arithmetic and it's not geometric because it's not multiplying or adding by the same number. And I can write for my pattern here that I first multiply by 2 and then by 3 and then by 4. The pattern would continue, but it's not labeled as a sequence because it's not a consistent number. I hope that makes sense for you. Now this one looks a little tricky because I first start with a decimal number. So I go 0.5 and then I go to 2 and then I jump to 4 and then I jump to 32. So again, my number is jumping quite quickly. And if this decimal at the beginning scares you, skip that and go to the next one and see if you can figure it out. So 2 times what gives you 8? Well, 2 times 4 is 8. 8 times 4 is 32. So those seem to be the same. And if I use my calculator and say 0.5 times 4, that equals 2. So we know that our pattern is multiplying by 4. and it's a multiplying pattern, which are called geometric. So you're gonna write G, and you're gonna write times 4. And then in order to find the next 3 terms, you start at number 32, you multiply by 4, I get 128 times 4 is 512 times 4 is 2048. You list G, A, or N, you list the pattern, and you list the next 3 terms. Here's another one for you. Now we have decimals again, but don't let decimals scare you. You can do decimals. We got 3.0, 4.7, 6.4, 8.1. It seems to kind of be going up pretty consistently. We're not jumping into a big number, which makes me think it might be an adding pattern. And if I don't know what I have to add in order to get these first 2 numbers, well then start with the second number and subtract it from the first one. So start with 4.7 and subtract 3.0. So in order to get from 3.0 to 4.7, I had to add 1.7. So now let's see if that's our pattern. 4.7 plus 1.7 equals 6.4. Looks like we got it. Plus 1.7 equals 8.1. So we know it's an adding pattern. So it's an A. I'm adding 1.7, and then the next 3 terms, I add another 1.7, I get 9.8, plus 1.7 is 11.5, plus 1.7, 13.2. So our pattern is adding. I'm adding 1.7, and here were my next 3 terms. So again, if you look at it and you are not sure what to add, start at the second term and subtract the first term. I could have done that with my multiplying pattern also. You can start at 8 and divide it by 2 to find out what your pattern is. 8 divided by 2 is 4. 32 divided by 8 is 4. So we know our pattern then had to be multiplying 4. So on your worksheet today, figure out, is it adding or multiplying a number? If it's adding, it's called A, arithmetic. If it's multiplying, it's G, geometric. List what the pattern is, and then list the next 3 terms. And if you just can't figure out a pattern, or if it is not a consistent pattern of adding the same number or multiplying the same number, then you're going to list that it's a neither. Even though this one did follow a pattern, I was multiplying by 1 bigger number every time, it can't be considered a sequence unless they're the exact same number. Let me know if you have any questions as you're working on this. Take notes on this so you can write this down and hopefully get some help. And I wish you luck as you work on sequences.